This is Dr. Ben Weitz with the Rational Wellness Podcast, bringing you the cutting-edge information on health and nutrition from the latest scientific research and by interviewing the top experts in the field. Please subscribe to the Rational Wellness Podcast on iTunes and YouTube, and sign up for my free ebook on my website by going to drweitz.com. Let's get started on your road to better health. Hello, Rational Wellness Podcasters. Thank you so much for joining me again today. For those of you who enjoy listening to the Rational Wellness Podcast, please go to Apple Podcasts and give us a ratings and review. That way more people can find out about our Rational Wellness Podcast. Also, you can watch the video version by going to YouTube. And if you go to my website, drweitz, drweitz.com, you can find detailed show notes and a complete transcript. Our topic for today is anti-aging medicine with Dr. Sandra Kaufmann. While there is a debate in the scientific community whether there's a limit to the human lifespan, it is generally thought to be 125 years, with only 48 people in recorded history making it to 110, and one recorded person making it to age 122. In the U.S. today, there are approximately 80,000 centenarians. Some anti-aging specialists distinguish between the lifespan and the health span, with the health span being the number of years a person is healthy. Others make a distinction between chronological age, which is the number of years you've been alive, and biological age, which is a measure of your physiological age, of your functional and health status. And some experts feel that this can be measured with the telomere test or other tests. In the scientific community and the medical community, anti-aging refers to the slowing, preventing, and reversing of the aging process. Part of this means detecting, treating, and preventing the diseases associated with aging, like heart disease, cancer, and Alzheimer's disease. But anti-aging medicine can mean different things to different anti-aging medical clinicians. For some anti-aging specialists, the focus is on restoring the body's hormones to the level of a 25-year-old by taking bioidentical versions of these hormones like estrogen, progesterone, testosterone, thyroid, and even growth hormone in some cases. There's been a lot of research in both animals and humans showing that caloric restriction may prolong life, 30 to 50% caloric restriction. But who wants to live longer and be miserable for most of that time? So recent research has looked at fasting and intermittent fasting and even the fasting mimicking diet, all of which seem to promote some of the same anti-aging pathways as caloric restriction. Others have explored the use of caloric mimetic substances, which might give us some of the benefits of caloric restriction without calorically restricting, including substances like resveratrol. For other anti-aging specialists, it means researching the reasons why aging occurs and finding interventions, whether they be changes in diet, lifestyle, exercise, procedures like cryotherapy, infrared saunas, hyperbaric chambers, or the use of medications or nutritional supplements to positively impact these biological pathways and processes. Dr. Sandra Kaufmann is our special guest today, and she has a master's in tropical ecology and plant physiology with a focus on cellular biology, and an MD degree with a specialty in pediatric anesthesia. She's the chief of pediatric anesthesia at Joe DiMaggio Children's Hospital and also at Sheridan's Health Corporation. She also has an avid interest in anti-aging medicine and has published a book on anti-aging, The Cauffman Protocol, Why We Age and How to Stop It. It's a very well-organized way of categorizing the most important molecular and physiological pathways of aging, and an analysis of some of the most efficacious nutritional and pharmaceutical compounds that can positively influence these pathways. She also has an app, and she constantly updates all of this information on her website, kaufmanprotocol.com. Dr. Kaufmann, thank you so much for joining me today. Dr. Kaufmann.
Absolute pleasure. That was a fantastic. Well done.
Thank you. So, as a pediatric anesthesiologist, how did you find your way to the anti-aging field?
Well, people ask me that all the time, and the reality is there's absolutely zero correlation. I take care of kids every day. Um, However, because I was a cell biologist and I spent a lot of time learning human physiology and pharmacology and all of the ologies having to do with medicine, I looked at myself and I decided I didn't want to age anymore. And I decided that all of the information out in the literature when I started this project seemed like mumbo jumbo. And I thought there had to be a way to look at it scientifically and clearly and organize it and then make it practical. So the reality is it has nothing to do with being a pediatric anesthesiologist.
Right. So, in your book, you break the concept of aging into 7 different physiological pathways or tenets of why we age. And then you talk about how we can slow down or reverse that aging process. Can you explain what these aging mechanisms, pathways are?
Absolutely. And I know you've read the book, so feel free to stop me if I'm skipping anything that you found interesting or important.
Okay.
But to back up just a little bit, people, when they think about aging, they think about their skin or their heart or their organs. And as a cell biologist, I took it down to the cellular level. And whereas all cells are not identical, they generally function roughly the same way. So if you look at a cell, I looked at all of the reasons that a cell ages and separated them out. People argue that you can't really separate them all out. If you think of it a Venn diagram, you've got 7 overlapping circles. Sometimes you can pull things apart and sometimes you can't. So some of my analogies may be a bit of a stretch, but I think it simplifies it to make it
Okay.
easier to understand. So that being said, so tenet 1, I call DNA alterations. People probably are already aware of this, but telomeres and such get shorter as you age, and that's a huge problem. The other category in the DNA issues have to do with epigenetic modification. I don't know if people are aware of that, but as your epigenetics changes, and that dictates what sort of DNA gets processed over time. Um, the good news is both epigenetics and telomere issues can be altered in a positive way if you know what you're doing. So that's tenet 1. Tenet 2 has to do with any energy production, which basically boils down to your mitochondria. Rate limiting issues in this category are free radicals from the oxygen issue, as well as nicotinamide deficiency. Issue 3 is pathways. And I talk about innumerable aging pathways, and different people have their favorites. You referred to caloric restriction in your opening comments, and that's basically activating your AMP kinase pathway. And that's by telling your body that you're starving, it puts yourself in a sort of state of hibernation. And that's how caloric restriction works. And you're absolutely right. We can take agents that fool your body into telling you that you're starving, which essentially just activate your AMP kinase. But there are also 7 mammalian sirtuin systems. These are my particular favorites because they do really cool things.
Right.
And there's also the mTOR pathway, and that sort of controls catabolism and the opposite, which is building of tissues. Gosh, I'm losing my words today. I'm quite sorry.
That's okay.
Let's see. The next pathway, or the next tenet, I call quality control, which is DNA and protein repair mechanisms, because over the course of time, things break and we have to fix it. I throw autophagy into that category, which is the recycling of organelles. The 5th category is security, which is your immune system. Your immune system goes haywire over the course of time for several reasons. The 6th category I think of as individual cell needs. What does a red cell need versus a liver cell versus a brain cell? And I also have recently thrown the senolytics in this because it's become a more active topic, and I just wrote a huge diatribe about that, so we can talk about that more. And the last category is waste management, because glucose is an issue, and then you get an accumulation of something called lipofuscin over the course of time. And I know that's a heck of a lot of stuff to swallow at one time, but those are the 7 tenets of aging. I'm so sorry.
No, that's okay. You know, there's a ton of stuff in this book, really good stuff. And I know all we can do is hit some of the highlights. But interestingly, it seems like a lot of people are talking about number 3. A lot of people are talking about the AMP kinase. We've had a number of discussions on a podcast about the ketogenic diet, which is supposedly hits some of the same pathways as fasting does. And a lot of people are talking about mTOR and how to block mTOR. And that's, for some reason, seems to be where a lot of the recent discussion in anti-aging in the functional medicine world that I've been hearing.
Oh, without a doubt. And I think what happens is people, especially the experts, focus on what they know. I call it the silo effect, of course. Some people are obsessed with, you're right, the mTOR, they're obsessed with rapamycin. Some people are obsessed with caloric restriction. Other people are obsessed with stem cells. And my take on the thing was, you're going to age for 7 categories. And if you don't attack each of the categories, you're pretty much spinning your wheels. And I don't care if you starve yourself till the end of time, you're still going to have issues with glucose. You're still going to have sirtuin issues. Your mitochondria are still going to fail. So I like to think of it as the need to have a more comprehensive program.
Right. So is there a way to analyze sort of where we're at? Like, how would a given person, is there a series of tests that they could do? You talk about glucose, I'm thinking about hemoglobin A1C. Is there sort of a panel that you can do to sort of get an idea of where you are?
That is a very excellent question. And we've been striving for that for many, many years. And if you go to readily available anti-aging clinics, they all have their favorite labs that they test. What's
Right.
very interesting is a lot of them mean absolutely nothing. And I don't want to pick on anyone in particular, but what was very interesting is I was recruited about a year ago. I don't know if you know who Bill Andrews is. He's sort of the telomere god. And I'm working on a project with him. And one of the pieces of the project was to put together the most comprehensive list of anti-aging markers. So between he, I, and a few other folks, we have a list of probably 400 markers.
Wow.
And we are initiating some studies to try to figure out which ones are the most efficacious.
So I was just asking you about, are there any tests so we can get a sense of where our level of biological aging is? And you were talking about the fact that you've been working on and looking at 400 different tests to sort of whittle down which are the most important ones. And I was just mentioning that I interviewed Dr. Russell Jaffe, and he felt that the 8 most important ones were hemoglobin A1C, HSCRP, homocysteine. He had his lymphocyte response assay, which is his sensitivity test, and first morning urine test for pH, vitamin D, omega-3, and 8-deoxyguanidine.
Well, that's quite a nice list. I can tell you, I mean, everyone has their favorite list, and they'll probably tell you exactly why. The reality is that no one knows quite yet.
Yeah.
But I will tell you that based on my 7 tenets of aging and all the biochemical things that I talk about in the book, I created a hierarchy of things to look for. So
Okay.
it started at the cellular level. For example, we could measure DNA destruction rates, right?
Really, how do you measure that?
So there's a chemical with an extremely long name, 8OH, blah, 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 that I won't bore you with, that you can actually measure DNA destruction rates. So the question would be, can you change that over the course of time? You can measure levels of sirtuins. You can measure mitochondrial rates. You can measure amazing things at a cellular level. If you bump it up to an organismal level, right, what can we measure in terms of GFR for your kidneys, for your lungs, for your heart? We can measure all of those factors. On a more systemic level, then you're looking at CRPs and that sort of thing. And then when you get to the higher level, you're actually looking at full body function. So we have a huge, unbelievably full list of labs. And as soon as we figure out what really is important, I will let you know.
Okay. What do you think about the telomere test?
I think the telomere test is fantastic. I think it depends on who does it. It's not the same from the different companies because we've tested a few different companies and the answers sort of range from place to place. But I think it does give you a very good indication. As you know, we lose between 47 and 67 base pairs per year, which is horrifying. And so it is an extremely important test. Is it absolutely linear as we age? No one really knows yet.
Right. So You have a rating system for judging potential anti-aging compounds. Can you explain what that is?
Oh gosh, yes. And I'm going to bore your audience to death here. I am so sorry.
Uh-oh.
This is called geeky science. No, so what I did is I decided for whatever reason that the 7 tenets should never change order. And after I figured out or decided that this is what caused you to age, I started looking up every agent that anyone said had any anti-aging properties. Because everyone has their favorite, Uncle Schmo takes this, and what does it really do, right? And that because this is the way people approach anti-aging. So I would look up Agent X, whatever it was, and I did a huge literature search in every category. Was it an epigenetic modifier? Did it affect your telomeres? What did it do to your mitochondria, et cetera? I mean, this took me an extremely long period of time. And it started out as a simple chart on my desk with pluses and minuses, and it got to be a little confusing. So it turned into a numerical rating system. So in any one given category, if an agent did nothing, for example, for your DNA, it got a 0. If it was amazing, it got a 3. And people say that's kind of non-specific. And the way I sort of did this is I call it the hierarchy of evidence. So theoretically, does agent X work in a test tube? For example, a transglycosylating agent. Is there evidence that it works in a test tube? If there's no evidence, then it's not going to do anything anywhere. If it works in a test tube, great. Does it work in a small animal model? Does it work in a culture? Those two things are backwards. And finally, does it work in humans? And if all of those things were true, it got a 3 in that category. Meaning it's very efficacious. It's
Right.
awesome, right? Lots of evidence to support it. So what happened, because there's 7 categories, each agent got a 7-digit rating number. So ultimately, these numbers became, I decided, additive or synergistic, such that when you wanted to create a program for yourself, you would line up whatever agents you thought were reasonable, add up the numbers, and then it became clear that some categories would be overrepresented and some would be underrepresented. So it serves as a good guideline to determine what each individual should be taking.
Okay. So let's go through some of these more important compounds, starting with resveratrol.
Okay. Well, so I hope you don't expect me to have remembered all of the numbers for all of these, because there's like 30 or 40 of them.
No, forget about the numbers. So, for resveratrol, I remember originally reading about it years ago. I think David Sinclair found that it would mimic caloric restriction, and he was researching the sirtuin pathways, and it was going to be the big key to anti-aging.
Oh, absolutely. And in fact, it is one of the keys of anti-aging because it does many things. And the rating number is very good in each of the categories for the most part. But the highlight is, in fact, what it does to your sirtuins. It activates most of the 1 through 7 of the sirtuins, which is extraordinarily important. The issue with resveratrol, which is sort of unfortunate, is the bioavailability is very poor. And this is what has baffled people for a long time. So there are 2 options. Option 1 was to alter the plan and go to something called Pterostilbene, which is, I call it a cousin, very closely related, higher bioavailability. It's in blueberries instead of wine. I always laugh that it's way less sexy because who wants to talk about blueberries? But it is more bioavailable. There are some information coming out lately that if you have high cholesterol, maybe you should stick with resveratrol over the pterostilbene. I think that's still in the beginning stages of understanding all that. But certainly I'll direct one or the other based on your cholesterol status. If you do, however, decide to take the resveratrol, I think you need to make sure you're taking something that's more bioavailable than the standard. Because the reality is the half-life is about an hour, and you need it way more than that in your system.
So what's a more bioavailable form?
So they put things in nanomyceles, which is my favorite way of taking these. There are a few companies that do this, and I don't want to cite any companies on a podcast because then I get busted by other companies. But if you're looking for something, you look for something that says bioavailable. Nanomyceles, there's a variety of different ways to package it.
Yeah, I mean, when I hear nanomyceles, I usually think of Quicksilver.
yeah, that's very true. But Rev Genetics does it. A variety of companies do it. It's just it makes it a whiff more expensive, but it's worth it.
And then, what's the kind of dosage you need for resveratrol?
Well, it sort of depends on which one you're taking. If you're
Okay.
taking, right, if you're taking a regular one, you're going to need more. If you're taking one that's more bioavailable, you need less. The half-life is probably about 6 to 8 hours. So if you really want to get a jump start, you could take it twice a day because daily dosing is based on half-life of the drug. It works in regular drugs and it works for this as well. Some
Okay.
people covering their bases, they take resveratrol in the morning and pterostilbene in the afternoon.
Right.
But it's a little zealous, but it just depends on what people want to do.
Right. And astaxanthin is one of those on your list.
Oh,
That's
astaxanthin is my favorite. I love astaxanthin. It's ridiculous. I have a love affair with the molecule. It's really quite sad.
it's basically a carotenoid that comes from seaweed, right?
It comes from algae. Yeah,
Algae. Yeah.
algae. My kids like to call it angry algae because it's silly. It's the slime that you see in bird baths. And when that slime gets stressed out in any way, as much as you can stress out algae, it makes this orangey red substance, and the stuff is amazing. And basically, it helps a plant survive, or it helps this algae cell survive, and it helps us survive via the same mechanism. It's the strongest free radical scavenger that we have at the moment, at least naturally produced.
Right. And I saw in your book, you also recommended it for athletes.
Oh, 100%. So athletes create more free radicals. Generally speaking, in your mitochondria, as you probably know, or as most people know, when you're looking at the electron transport chain, oxygen is the final receiver of the electron. So that's why you need oxygen. Unfortunately, for normal resting folks, 1 to 5% of those electrons or that oxygen becomes radicalized, and that's bad. In the world of good and bad, that's bad. So in athletes, you're using more oxygen, so more oxygen gets radicalized. So you've got more free radicals floating around, and experts that are lazy use this as a reason not to exercise, which is ridiculous. But athletes need more free radical scavenging, especially if you're outside, because it also protects your skin.
On the other hand, some of the studies show if you take too many antioxidants, you may reduce the benefits of exercise.
Well, so what people don't understand as well, and Ben Greenfield, I love him dearly, but it's hard to understand. Exercise and aging are two very separate things. What's good for one may not be good for the other, right? Some feedback of free radicals does in fact help your body work better. It does.
Right.
And there's truly no way to get rid of all of the free radicals. So I think that's a little bit ridiculous. But the example sort of holds true as well when you're talking about the mTOR system, right? To not age, we want to shut down the mTOR system. To be an athlete, we want to activate the mTOR system. So you need to know what you want to do before you plan how to get there.
Yeah, when I work with athletes, we usually try to time the antioxidants and not have them say, if they're exercising in the morning, not have them right around the time they exercise and say, have them in the evening.
Right, that's perfectly reasonable. Absolutely.
Because there have been several studies seeming to show that when you take these antioxidants, they blunt some of the benefits of exercise.
That's absolutely true. But you need to also keep track of what type of athlete it is, right? Is it a resistance type problem? Is it an aerobic type problem? For example, my daughter, and I talk about her frequently, is a tennis player. She is out in the Florida sun all the time. She's a redhead and she burns. When she takes her astaxanthin, she does not burn.
Cool.
The correlate, of course, she forgets all the time and then she turns into a beet. So we know that it works because we've done this controlled study now. So it just sort of, again, it depends on what your absolute goal is.
Right. It's interesting. A lot of the focus in anti-aging medicine these days is all about cleaning up dead older cells and putting your body in this mode in which it thinks it's starving to death. So it starts eating up the old dead cells, autophagy, which is something that exercise also does. Whereas a lot of the focus 20 years ago in anti-aging was about doing things that increase your potential for growth as opposed. And so a lot of the focus was more on giving testosterone and growth hormone and various strategies that are going to increase growth because as we get older, our cells break down and need to be replaced. So I think there's this kind of yin and yang between having your body be in growth mode and be in the opposite mode.
I think that's completely true. I think you're mixing a whole lot of subjects there, so I'm going to try to tease out what I think is important, and I don't mean that in a bad way at all. I think before 15-ish years ago, we didn't know a whole lot about not aging. I really don't. I think we do now, but people do have various opinions. When you talk about all of the hormones, I think it's, and people are going to hate me for this, I think it's a little crazy, to be perfectly honest with you. Our bodies work on feedback loops. So if you are a young man and you take testosterone, your body perceives that testosterone, especially if it's bioidentical, and says, oh, I don't need to make any more because I have enough. So
Right.
it shuts down. So you're not going to end up with any higher levels of testosterone. And in fact, you're going to hurt yourself over the course of time.
Sure.
I generally tell men, get the levels tested. As you are getting older and they fall, it is not unreasonable to replace them. But trying to jack yourself up when you don't need it is, I think, horribly painful. I mean, I think it's just
Oh,
a bad thing.
absolutely.
So I don't believe in any of that. What what the other thing that you mentioned is clearing out the bad cells. And now this is a huge new topic. And what you're talking about is senescent cells. And I just spent months and months and months digging into this so I could bore you to tears. But in general, a senescent cell is a cell that was a normal acting cell, and it had some DNA damage, and it decides to go into a shutdown mode, right? And the shutdown mode does then, the outcome is one of three things. Either one, the DNA damage is absolutely horrible, cell can't fix itself, commits cell suicide called apoptosis, and just sort of disappears. Or the DNA is fixed, and then the cell goes back to doing what it should do. But in the middle, we have these things called senescent cells, where the cell starts again, but it's not exactly the same as it was before. The analogy that I like to use is the grumpy old employee at a factory, right? He used to be young and vivacious, and now he's the fat guy in the corner, right? So these senescent cells, they change shape, they become larger, their organelles change shape, their production change shape, and what they do is they produce something called an SASP. Basically, they put out what I call evil cytokinins. It's a senescent associated secretory phenotype for those geeks out there.
Okay.
But essentially, they're just bad, evil, grumpy cells. But they accumulate over time, and they create a localized inflammatory issue. We think originally they did this to bring in immune cells to get rid of those cells, but it doesn't exactly work that way. And as you get older, these cells accumulate, and they cause more pathology and more inflammation and more damage. I'm not completely sure of this, but I developed a graph where, while you are still young, you have some senescent cells, and the increase is very small. As you get older, the slope of that increases, and then beyond some point, it's sort of when people just feel old, it becomes moderately exponential. So the question is, how do you get rid of these cells? And so we've been looking at drugs. There's xenomorphics, which change how a cell acts. And the good news is there are senolytics that actually kill these cells. And it's been shown in animal models that if you can kill these cells, where the cell was, it gets replaced by normal new cells. So a lot of regenerative medicine can be actually focused around senolytic therapy. So I think that's a really cool thing.
Absolutely. So another substance that you highlight is nicotinamide riboside to stimulate NAD production.
Another one of my favorite subjects.
Yeah.
Okay.
A lot of people talk about this, and then there's some controversy over which of the various compounds that are available are best to take, whether you're going to take nicotinamide riboside, or whether you're going to take NMR, or whether you're going to take NAD, et cetera, et cetera.
Yes. So first we'll start off with what it is and why it's important, and then I'll tell you what I feel about the other stuff.
Okay.
So nicotinamide is important because, number one, it is very active in the electron transport chain in the mitochondria. So as you get older and you have less nicotinamide, and we'll talk about why that happens in a sec, you make less energy. You just do. Your mitochondria just don't function efficiently, which is why a lot of older people just don't have the energy that they should have. So that's problem number one. Problem number two is that it is a necessary cofactor for sirtuins. So the aging or not aging pathways, the 7 mammalian sirtuins, do not function without nicotinamide. So you can take as much resveratrol or pterostilbene as you want, and without nicotinamide, you're not doing anything. So that's number 2. Number 3 is that when you have DNA damage, you get a big glob missing in your DNA chain, your body takes the nicotinamide molecule, chops it into pieces, and puts part of it back into the DNA so it fixes it. So again, if you don't have DNA, you're not going to repair your own, I'm sorry, if you don't have enough nicotinamide, you don't repair your DNA, then you get cancer. And then lastly, and this one's hard to sort of quantify, serves as a communication device between your nucleus and your mitochondria. So 4 reasons that you need more, because you have more damage, you need more energy, blah, blah, blah. So as you get older and you have less, you by definition need more. So the supply-demand chain makes it very difficult to keep up, which you can actually get your nicotinamide levels measured, but it's extraordinarily hard to do. We have tried to do this. There's one company in LA, I believe. We measured a gentleman's nicotinamide, and it had to be immediately spun down, put on dry ice, and hand-driven to their company to do it. So at the moment, it's not exactly commercially available.
And niacin levels are no reflection of that.
Not at all. Completely different. Completely different. My kids always tell me that, why can't you just smoke a cigarette? Because isn't that the same thing? And the answer is, gosh, I hope not. And I hope other people don't think that either.
Because nicotine being a similar compound?
Well, the word sounds kind of the same. And so people go, oh, well, I smoke, I'm fine. And the answer is not exactly, actually not at all. And then you're making the problem way worse because now you got more DNA damage.
Right.
Right. So the question then goes back to, how do you know that you're short? And the answer is probably anyone over the age of 40. People that say, I just don't have the energy I used to. That is probably a nicotinamide deficiency. Or you really know? Not really, but it's just likely. And then, of course, which one do you take, right? There's no way of knowing because there's no way of measuring it. People are touting NAD infusions, and I think that's kind of crazy because I've worked in a hospital a really long time and no one's ever come in a stat nicotinamide deficiency. It just doesn't happen. There's no, right? And giving something extremely quickly, it's going to get metabolized and then it's going to disappear. I'm not convinced that's great for you just from a pharmacological standpoint. What I think you do need is slowly filling the deficiency, which you can do obviously with oral supplementation, which then boils down to, you're right, is it nicotinamide riboside or the NMN? And the answer is we don't know that either. There's never been any head-to-head testing. There's been a lot of studies that show that NR is very efficacious. They're catching up on the other side. I think this is a war of companies because they both have their trademark compounds. We know that you need it in some form and someone ultimately is going to win. I wish they would do a head-to-head study because people ask me all the time, which is better? And the answer is, I really don't know. I wish I had an answer. But taking one of them, I think is crucial.
So if you take nicotinamide riboside, what dosage do you like?
It's a good question. I think it depends on how old you are. I think it depends on how deficient you are. Just many, many things. For example, if you're already 50, you got some catching up to do. So I recommend a higher dose. You probably would take maybe 2 weeks to 3 weeks to catch up. When your energy levels sort of level off.
What would that higher dose be?
I would say, it just depends on the bottle too. I think they usually come in 250s, I believe.
Right. I think they do.
So I tell people, take 2 of them, spread it out, 1 in the morning, 1 at night, for 2 to 3 weeks until you feel like your energy levels are good. Back down to once a day. And if you still feel good after a month or so, take it every other day. Because having too much isn't good either. This is not a, who gets to have the most in their body wins sort of thing. You need the right amount, but not too much. And the only way to do that is judge it by energy levels.
Curcumin. That's one of my favorite nutritional compounds, and I know that's big on your list.
Oh, I love it. Yes, absolutely.
Yeah, we love curcumin as an anti-inflammatory, as an anti-everything, cardiovascular, cancer prevention, et cetera, et cetera.
It absolutely. And I used to think that it was really crazy that one thing could do all of those things. But if you boil it down to the 7 tenets, it does. It is a very potent epigenetic modifier, right? So everyone should be on it. It helps your mitochondria because it's a free radical scavenger. It helps activate some of your pathways. It helps with DNA repair. It does
Yep.
everything it's supposed to do. I won't bore you with the details. Although one of my absolute coolest favorite things is it's the only thing that's actually been demonstrated to help with lipofuscin accumulation. There's a
Okay.
great rat study. They looked at, old rats and medium old rats, and if they were on curcumin, not only did they not get a lot of, or get the same amount of lipofuscin accumulation, some of it was actually reduced, which I think is incredibly amazing.
Can you explain what
Like,
lipofuscin is?
absolutely. I call it the kitchen drawer phenomenon. You probably read that in the book. It's sort of a goofy analogy. So when a long-acting cell responds to the environment, it changes the number and type of organelles it has. So for example, over the course of time, your mitochondria get beat up in your brain cell. It says, you know what, I really need to make new mitochondria, squashes them down, extracts out the reusable pieces and takes the rest that it can't use, it squishes it in the back of the cell. And then over the course of however old you are, 90, 80, however old you are, every time you've recycled these organelles, you get more and more and more accumulations of just gunk sitting in the back of your cells that you can't use. And it really doesn't do anything. It's just a space occupying problem. And what I think is really cool is you can age lobsters by lipofuscin accumulation. So not that that's really important to anyone, but it's just really cool. It's the most accurate way of measuring crustaceans. And the same with us. You cut open our brains when we're old, you can probably look at it and go, aha, 90 some years old or 100 or however old we are.
Right. So when you were talking about NAD, I believe a lot of people talk about it as a factor that affects mTOR, right? Is it a mild blocker for mTOR?
NAD should not be. No,
Okay.
metformin is. If that's what you're referring to.
Oh, okay. Okay. We'll get to that in a minute. Okay. So next we have carnosine.
Aha, carnosine. You're
Yeah.
hitting my top favorites here. This is great.
Yeah. So most people probably don't know carnosine. They know carnitine, and carnosine is a little bit different.
It is different. It is a dipeptide. It is alanine and histidine. So it's a very simple peptide. The Russians are very, very fond of this. They gave it to all of their athletes behind the Iron Curtain, and honestly, they kicked our butts in the 80s, and I think it's because of the carnosine. It does two major things. Number one, it's a buffer in your muscles, and it's a free radical scavenger, which is why athletes like it. But I am in love with this because it's a transglycosylating agent. So all of the glucose that we take in our system needs to get stripped. And it's one of those things that can actually suck the sugar off of you, and you just excrete it, and you are all the better for it.
Okay. Yeah, we know that blood sugar, insulin resistance are major factors in anti-aging, and we need to try to manage those. And I think that's one of the benefits of caloric restriction, fasting, and probably of ketogenic diet as well.
Oh, without a doubt. Glucose control is extremely important. Obviously, we need glucose. It's just like oxygen. We need some, but we all have far too much.
Right.
Glucose falls into my waste management category just because it's everywhere. I tell people it's sticky on the outside. It's sticky on the inside. You get glycation everywhere. I talk about AGEs in the book a lot. One of my favorite abbreviations for its advanced glycation end products.
Right.
A glucose sticks to protein, it sticks to DNA, it sticks to lipids, and it causes several problems. It causes the things that it sticks to lose function, and then the glob sticks to collagen. And once a glob sticks to collagen, you get basically destruction of anything that's collagen-based, in your body, your skin, your heart, your blood vessels. So I think it's one of the huge reasons that you age. So by calorically restricting yourself, as well as taking less glucose, obviously you're causing fewer than those problems than you could normally.
And when we measure hemoglobin A1C, we're measuring one of those glycosylated proteins, right?
That is correct. So basically, you are measuring the amount of glucose stuck to a red cell. Red cells take about 3 months to turn over, so it's a transient snapshot of your glycation level. If you really want to know how coded you are, there's a great machine. It's called an AGE reader. They have it in Europe.
Really?
Absolutely. I wish I could. If I had a private clinic, I would get one, but I don't, so I haven't.
AGE reader.
It's
Wow.
called an AGE reader. You stick your arm in it, and it tells you how much glucose has been glycosylated into your arm.
Wow. Fascinating.
I think that's the future of tracking diabetes. It just hasn't made it to this country yet. It's on our list of anti-aging markers, so we'll get to play with it. It's just not a popular item yet.
You know, I've talked to some anti-aging doctors. I talked to Sarah Gottfried recently, and she likes to wear a continuous glucose monitor just to continuously see where her glucose levels are. What do you think about using something like that so you could really fine-tune your glucose levels?
I think it depends on your level of OCD. I know that sounds terrible. So, I mean, some people are very, very into this, and I applaud that. My whole plan of this whole thing was to live a normal life and not to be too crazy. So I think that would just drive me to drink, to be perfectly honest, which wouldn't be good either.
Well, you get plenty of resveratrol as long as you had red wine.
Oh, absolutely. And there's quercetin and white, so we're covered either way. So that's good.
There you go.
No, but so the way I approach it is I block glucose going in, metformin. There are 7 steps to glucose being becoming an AGE, and there are innumerable substances that serve as blocking agents. And then once you do have an AGE, there are several agents that can transglycosylate to get rid of it. So I just don't actually care what my momentary glucose is. I go on my Harataki holidays, and maybe I'm kidding myself, but I like to think that I'm sort of taking care of the problem.
Cool.
You have nothing to say to that, do you?
Well, I just had something pop up on the screen that Zoom sent me this note that we've just eliminated your 40-minute limit. So,
oh, great.
Yeah, there's this weird thing that if you have 2 people on a meeting, you get unlimited time. But if you get a third person because you switch computers,
oh no,
they limit you to 40 minutes, and they just
popped
up, and you didn't see it. I guess it said we eliminated that. I was like, thank you. Okay.
Oops.
So you mentioned Carnosine eye drops. I never heard of that. That sounds really fascinating as a way to reduce risk of, I think you said, cataracts.
Right. So it's, again, this Carnosine falls under the expertise of the Russians. And there's some extremely zealous Russian dude with a ridiculously long name that I can never pronounce. And he loves Carnosine. And he decided that cataracts, and I think by extension presbyopia, has a lot to do with glycation in the lens. And interestingly enough, he formulated NAC, so it's N-acetylcarnosine. And he gave it to 50,000 Russians, and they all said their vision got better.
Wow.
So amazingly enough, it's over the counter. There's probably 17 versions of it on Amazon.
I looked online because I read about this on your website. But what do you think is the best one to take?
So I tried a whole bunch of them, and I don't know why. Some of them burn and some of them don't. I get this one, and this is the most ridiculous ad ever, but it comes in a little metal bag. How about that? If you're looking for it online, it comes in a little foil bag.
Okay.
I know that's really silly. It says NAC. It's a tiny bottle. I wish I could tell you exactly who made it. I can work on that, and I can send you a link.
Okay, so now in your list, most of your list of compounds are supplements, but you have metformin, which is a pharmaceutical drug.
Wait. All right, so I have to interrupt you there because this drives me absolutely nuts. Okay, so a supplement technically is something that you already have in your body, and we're adding to it, right? An adjuvant is something that your body's never seen before, right? Then there's vitamins, and then there's minerals. So I call them molecular agents because everything falls in a different category.
How about if we use the term nutraceuticals?
That's fine. We can use that.
Okay.
But metformin, the only difference of metformin is that somehow it became controlled by pharmaceutical companies. As far as I'm concerned, it falls into the same categories.
I'm sorry, that makes it evil.
It does not make
I'm kidding.
The only good news, it's been around for a zillion years, so it's extremely cheap.
Right. Metformin helps with controlling mTOR. What about rapamycin? I've heard some anti-aging experts, I think Peter Attia talk about, I think he's been experimenting with taking rapamycin.
Right. So you have to know, so the mTOR pathway, I call it the youthful pathway. It's about
By the way,
building.
mTOR stands for a mammalian target of rapamycin.
Yes, yes, it does. Yes, it does. And I should have said that. In my world, that's sort of a given, so I apologize. What the mTOR pathway does is it builds. It builds muscle, it builds tissue, it turns over cells. It's a very active system. It's anabolic, right? Versus other things that are catabolic. As you get older, however, its system becomes obsolete. And if you block it, you put yourself into a sort of state of not growing. And that helps to preserve you, right? Therefore, rapamycin is extremely potent, and it can do this, which is why we use it. It's truly is a chemotherapy agent. We use it in stents so that you don't regrow tissue in a coronary artery. We use it to block issues after kidney transplant. I mean, it's a heavy-duty medication. And if you block all tissue turnover, you may preserve yourself. However, I spent a ton of time looking into this, and the problem is that you block tissue that you need to turn over. For example, you tend to become sarcopenic, right? Because you've got muscle wasting because you're now turning over your muscle. And the other thing that's a little bit worrisome is that you have to turn over your hippocampal cells to make memories. And at least in experimental animals, if you block that ability, you're not going to remember anything. So I don't necessarily agree with the rapamycin bandwagon. And
Right.
other people will say different things, but that's sort of my take on the situation.
So just practically, how would, now you're an MD, I'm a chiropractor. I can't recommend pharmaceutical drugs anyway, but even if I were to suggest the patient take metformin for anti-aging, practically, what are they going to do? Go to their primary care doctor and say, hey, doc, I want to live a long time. Can you prescribe metformin?
So the answer is yes. Metformin, so the study came out how many years ago? 4 or 5 years ago by now. And it looked retrospectively at 3 groups of people. There were diabetics on metformin, diabetics on sulfonylureas, and non-diabetics on obviously no diabetic drugs.
Right.
And retrospectively, the diabetics on metformin did extraordinarily better. The morbidity was lower, the mortality was lower. So clearly people realized that metformin was doing something to help with not aging. And it certainly was not just the glucose. So a lot of money and time has been dumped into figuring out why metformin does this. And it does many things. It's an epigenetic modifier. It activates your AMP kinase. It helps with glucose issues. It's an anti-inflammatory. We know it reduces the risk of cancer in diabetics. It reduces weight. It helps with menopause. It decreases issues with PCOS. It is an extremely potent, useful drug. And people are realizing that in a risk-benefit ratio, it really is a great thing to take. And I've actually gotten calls from a lot of primary care specialists saying, people are asking about this. What should I do? And I say, you know what? Give it to them. Absolutely give it to them.
Well, there's studies showing that a natural compound, berberine, has been shown to be equally effective to metformin in some situations. Could we take berberine instead of metformin?
So the answer is sort of. That plant or that chemical does actually help with glucose reduction, but it doesn't do a lot of the other things. So what you would have to do in order to substitute that is go to my numerical chart and find agents that helped in the categories that you are now not using from the metformin. So this goes back to my idea that you don't have to be on everything, but you have to just make sure all of the categories are covered. So for example, if you're going to use berberine for glucose management, you need to use something else for the AMP kinase or the inflammatory issues.
Okay, interesting.
The caveat, and I just like to say this because people run out and then they buy metformin or they talk someone into it, because it is a partial mTOR inhibitor, you can get muscle wasting over the course of time. So I recommend that people take leucine, one of the branched chain amino acids, to try to prevent it. And then secondly, you get decrease in vitamin B absorption in the gut from it. So I suggest people take sort of like a generalized B. People love B12 for some reason, but you really need all of the Bs.
Interesting. So leucine.
Mm-hmm.
There's some controversy about amino acids playing a role in aging, and some specialist anti-aging folks feel that that certain amino acids, like methionine in particular, are contrary to an anti-aging perspective. What do you think about that?
I think it goes back to what we talked about before. You have to define what you really want to get to, right?
Right.
If absolutely, amino acids cause you to build muscle.
It's one of the arguments for a vegetarian diet, in say having anti-cancer effects.
Right. And I get that. But again, you have to pick your battles. If you're going to protein starve yourself, you're going to become extremely sarcopenic, right? And if you're an aging athlete, you don't want to become sarcopenic. So I tell people not to take all of the amino acids that you see in those big giant bulk cans for the bodybuilders. But if you want to maintain some lean muscle so that you're not frail as you get older, the only one that you really have to focus on is leucine.
So you take the branched chain aminos.
That's exactly what I do.
Right. Okay. So we can't go through every one of your compounds, even though they're all fascinating. But I wanted to mention that astragalus TA65 compound that I've seen at some conferences advertised, and I've read some of the literature on it. I know it's an extremely expensive one. Can you talk about that and how efficacious is that as an anti-aging compound?
Right. So it is extremely important to activate your telomerase to make your telomeres longer. And the question, of course, is how do we do that? The natural agent, astragalus, as you mentioned, has pretty potent powers compared to the ones that we've concocted in the lab. It's pretty weak. TA65 is pretty good. You can thank Bill Andrews for those because he invents them at CR Sciences and then passes them along. The 818 is even better, but again, these things are ridiculously expensive. So for those billionaires out there that really don't care about cost, it is a great thing to do. It really is. For regular human that just wants to stop aging, it probably is not going to be very affordable. I personally stick with astragalus. Do I expect phenomenal things to happen? No. But the other really cool thing about telomeres, and I actually just learned this recently from a very brilliant scientist from Spain, is that as you exercise and you become transiently hypoxic, you actually activate something called your...
What was that?
When you are exercising, right? And you feel that acidotic burn, you're getting transient hypoxia in those areas. Okay. That activates...
Not enough oxygen in those muscles.
Right. Contrary to what a lot of people think, more oxygen is not good for you. Sitting in an oxygen chamber, unless you're a diabetic, is not so good for not aging.
Because it's reactive oxygen species, right?
Yeah, for innumerable reasons. Yes, our stem cells
what's good is bad too, right? So that's why people use hyperbaric oxygen and ozone, because it's inflammatory, but then it stimulates the healing, right?
Right. I mean, again, you have to figure out what your end game is to figure out what your therapy is going to be. And what's good for one person is not necessarily good for someone else. That being said, when you transiently become low in oxygen in your muscles as you are exercising, it activates something called the HIF alpha factor, which also gets activated when you're climbing mountains and you're hypoxic. And that, through a series of enzymatic reactions, actually activates telomeres. So simply by exercising, you're actually activating your own telomeres. And that's probably the most potent thing that normal, reasonable people can do.
Now, I think that there's been studies showing a whole series of things lengthen your telomeres, including multivitamins, fish oil, on and on and on. And so I think it's led some people to be a little skeptical about the telomere hypothesis.
Well, I think it boils down to telomeres are much like epigenetic modification. Whatever your mom said was good for you probably is a positive epigenetic modifier, and it probably helps your telomeres, right? And the other thing you have to realize is that all of your telomeres in every cell of your body are not going to be identical all the time, right? So if you looked at a telomere from your brain cell, it's going to be different than a telomere from your white cell or from your red cell, right? It's not an absolutely homogeneous population. So it's just, you have to realize that once you have your telomeres measured, it may be different if you took a different specimen. You know what I'm saying?
Yeah. So the telomeres in the bloodstream may not reflect the telomeres in the brain versus the telomeres in the liver or in the muscles.
Right. Right. But going back to like what your mom said, right? Clearly she said don't eat Twinkies. We all eat Twinkies as kids. Twinkies are clearly negative epigenetic modifiers, and they certainly cause a lot of stress on your body. Stress causes decreased telomeres. So again, all of this is what I like to think of as a giant overlapping Venn diagram where you can't necessarily say this does this, but it doesn't do that.
So how do we put together a list? How would I put together a list, let's say for myself or for one of my patients, using your system? Bam, what's the list of 6-8 compounds I would come up with?
Excellent question. So first thing I do is how old is someone? How zealous do they want to be? What medical problems do they have, right? Someone says, I'm middle-aged, don't really have too many medical problems. My back hurts, I've got disc problems, and I don't have any energy. I immediately put them on the panacea. And conveniently, it's the panacea because I rearranged some letters at some point and kind of, misspelled panacea on purpose, and it kind of worked. So, but it works. So so the P is Pterostilbene.
Okay.
A is Astaxanthin. N is nicotinamide. And then you throw in 2 C's, which are Curcumin and Carnosine. And then for some people, I throw in the EGCGs from green tea because it helps a lot as well. So to a basic program, that's a great place to start.
Cool.
But if you want to be fancy, right, some people go, you know what, I have a lot of immune problems. Then you add more agents that score well in that category. Or if you're a diabetic, pre-diabetic, like to eat a lot of junk food, then I add up a lot of things that score well in the waste management category. So there's actually an app, and unfortunately, people are angry at me right now. My developers it gets stuck on the the subscription page. So please don't have anyone do it until I absolutely get it fixed because I'm getting tired of getting hate mail. But what it does is you put in all of your personal information, and then an algorithm based on what I have done sort of tells you what you should take and then where to get it. Trying to make it easy for people.
What about the role of, we've been talking about supplements and we've been talking, not supplements, we've been talking about nutraceuticals.
Oh, there you go.
But what about the role of diet, exercise, sleep, stress reduction techniques like meditation for anti-aging benefits?
All of those things are good, right? The question would be, why? Well, exercise is good, right? We talked about telomeres. It actually activates your sirtuins, increases your circulation. It does a variety of fantastic things, right? You need aerobic, you need anaerobic. Everyone knows it's good for you. And I actually rated it at one point to figure out exactly what it did in each category. It scores pretty well. Foods are important because they're epigenetic modifiers. They really are. And what's really interesting is if you take twins and you watch them grow up, they get more and more different as they age. And the reason is it's all epigenetic modification. That's their diet. Or are they around polluted areas? Do they smoke? What do they do? So you could absolutely do great things, right? Meditation and all of those things, they reduce stress level. Stress level reduces stress on cells. Cells work better, i.e. you're not aging as much. So it all ties together. You just have to boil it down to what exactly it's doing to your cells.
Cool. Awesome. So I think that's all the questions I have. I thought that was a lot of really good information to help us with aging better and hopefully living healthier. How can our listeners get a hold of your programs and your information and your book?
Excellent question. So glad you asked. So we'll start from the beginning. As you well said, I am not an anti-aging specialist per se. I don't have an office. This is a hobby.
When is that office opening?
That's a very good question. This is really starting to not help my day job. I run an operating room, and every now and then I'll get a phone call, and they're looking for me, and I'm like, can I help you with an anesthetic? And they're like, no, I don't want to age. And then I'm sort of moderately perplexed because it's hard. Anyway, whatever. So what I do is the book is available. It's on a regular book. It's on an ebook. So hopefully people can sort of get through that. The app, don't get it yet. I'll tell you when. There's a website. It's kaufmanprotocol.com, and explains all of these things that I'm talking about. I will be sending out updates. I'm sending out so actually Bill Andrews is reviewing my diatribe on senolytic cells right now. He's on a trip back from Japan. Assuming I get his blessing, that's going to go out on the website. On Facebook at Sandra Kaufmann. I'm on Instagram at Kaufmann Anti-Aging.
Is that a book or a paper?
You know what? It started to be a paragraph and it turned into 30 pages.
Okay.
So I don't exactly know what it is. It was all the information that I thought was important. Um, my next project, I actually have a playbook for athletes, specifically anti-aging playbook, or anti-aging for athletes, which is sort of interesting. And I'm working on a book for skin, because your skin ages for 9 reasons instead of 7 reasons. So hopefully
Yeah,
that will
I
be
was
out
very
shortly.
excited to do that pinching thing, and my skin didn't.
Uh-oh.
It went back immediately. I didn't have any line at all. So,
Oh, fantastic. Then you're doing well.
and I'm
Doing great.
61. So,
Fantastic. Fantastic. So the really big question here is, what do you take?
oh, I take about 30 different things. Yeah, I take a lot of these. I'm big multi, curcumin, fish oil. I take vitamin E, vitamin C. I take the gamma tocopherol, vitamin E. I take C. I take Berberine. I use that as a natural blood sugar control agent. I take Astaxanthin. I take the nicotinamide riboside. I take Resveratrol. I take alpha lipoic acid.
Excellent.
So and that was before I read your book.
Oh, good. So you're probably then agreeing with all this crazy stuff, thinking, that's why I do it.
When I get up in the morning, I add a green powder, a red powder. I put fiber. I put probiotics. I put modified citrus pectin. So yeah, I do a lot of stuff.
Perfect. That's awesome.
Way more stuff than I would ever ask a patient to take.
Well, you and me both. If people looked at my list, they'd probably have a heart attack.
Absolutely. Okay. Thank you so much, Dr. Cauffman.
It's been a pleasure. Thank you.
Okay.